Dear student, in previous class I was discussing regarding the time response of the first order system and also the examples on the first order system. Today class I am going to explain you regarding the time, how to find the time response of a second order system. Before that, I am going to explain what is the damping ratio and what is the underdamped system, what is undamped system, what is critical damped system, what is the overdamped system. These things are very important, and also the natural frequencies, damped natural frequency and also the natural frequencies. Now, the damping ratio, we know that this is a symbol zeta can be used for indicating the zeta is indicating the damping ratio. It is the ratio of the actual damping to the critical damping. It is the ratio of actual damping to the critical damping. Now this is the dA divided by dC. Now what is the critical damping value? This is a 2 into square root of m into k. This is for the mechanical translational system, m into k. Critical is equal to 2 into square root of j into moment of inertia into kt. The torsional spring coefficient kt is for the rotational system. This zeta is equal to 1. Based on this zeta value, we can classify the second order system can be classified into 4 types of undamped system, underdamped system, critically damped system, overdamped system. If zeta is equal to 0, when dA is equal to 0, then automatically zeta becomes 0. And then the system becomes undamped system. When dA is less than dC, critical damping, actual damping is less than dC, then the system is called as underdamped system. And then zeta value less than 1. If zeta value is less than 1, then such a systems are called as the underdamped system. If zeta is equal to 1, and then such a systems are called as a critically damped system. And zeta is equal to 1, and then the overdamped system. Based on the second order, based on the damping ratio, the second order system can be classified into underdamped system and undamped system, critically damped system, or damped system. Zeta is equal to 0, undamped system. Zeta is less than 1, underdamped. Zeta is equal to 1, is called a critically damped. Zeta is equal to greater than 1, then it is called as a overdamped system. I'm going to next important term. So used in the second order system is the undamped natural frequency and damped natural frequency. Undamped natural frequency. This is denoted by W of n. W of n is called as a undamped natural frequency. It is defined as a natural frequency of the system in which there is no damping. It is defined as a natural frequency of the system in which there is no damping is provided. There is no damping is provided. It is denoted by the symbol W of n. Now what is the value of damping? W of n is equal to square root of k by m. This is for the mechanical translational system. W of n is equal to kt by moment of inertia, j radians per second. This is for the mechanical rotational system. Now this term is also very important. Damped another is called as another term, damped natural frequency. It is denoted by the letter W of d. It is defined as a natural frequency of the system in which damping is provided. If damping is not provided, then it is called as undamped natural frequency. If in which it is defined as a natural frequency of the system in which damping is provided, then such a frequency is called as a damped natural frequency, which is denoted by the letter W of t. Now, what is the relation between natural frequency, undamped natural frequency, and damped natural frequency? Now, this is a very important. So, while solving the problem, this term is also, we should remember W of t is equal to W of n into square root of 1 minus zeta square. Now I'm going to discuss the time response. I need to discuss regarding I need to derive the time response of a second order system, underdamped system for unit step response. For unit step response. to find the time response of a second order system, second order underdamped second order system for unit step input, consider the block diagram of the closed loop system. Now this GS is called as a feed forward transfer function. H of is called as a feedback transfer function. Now if I GS is equal to feed forward transfer is equal to, for the second order system, the what is GS value? The GS is equal to W of n squared S divided by S into S plus 2 zeta W of n, no, and H of S is equal to 1, no. Suppose after, now for the second order system, what is the standard value of G of S value? We should remember this also. W of n square divided by S into S plus 2 zeta W of 2 into W of n, no. Now this is the GS value for the second order system. While for solving the problem also, or we should remember this quantity, GS quantity is for the second order system, GS is equal to W of n square S into S plus 2 zeta into omega n. No, this consider the block diagram of the closed loop system. Closed loop system. Block diagram of the closed loop system. Now, after finding block diagram of the closed loop system, after writing the block diagram, here that this is the GS value, HS value is equal to now. Now find the value of now find the once we find the block diagram of the block diagram of the closed loop system, assume GS is equal to, this is the GS value, and HS is equal to for unity feedback system, underdamped system for unit step input, therefore negative unity feedback system. Therefore, find now what is the CS values. Find the what is closed loop transfer function. The closed loop transfer function is nothing but the output of divided by output of the system divided by input of the system is R of S divided by R of S. Now what is the is equal to, the standard equation is the GS divided by 1 plus GS into HS. Now what is the value of GS? Now GS value is W of n square. That is GS value is E of S divided by R of S is the closed loop transfer function of the this closed loop system. Now GS value is W of n square divided by S into S plus 2 zeta W of n divided by 1 plus W of n square divided by S into S plus 2 zeta W of n into H of S value is equal to 1. Now after simplification, W of n square by, if I take the LCM, then after simplification, now this is the quantity S square plus 2 zeta plus, now this is the is the closed loop transfer function of the second order system. Closed loop system of the second order system. C of S divided by R of S is equal to W of n square divided by S square plus 2 zeta W of n plus omega n square or 2 zeta omega n plus omega n square. Now I want to find out the output in S domain. C of S output in S domain is equal to input R of S into this transfer function. So therefore the next now what is the output? Output in S domain. Find out the what is C of S. Now C of S is equal to R of S into W of n square. This is the W of n square divided by S square plus 2 zeta omega W of n plus W of n square or omega n square. For unit step input, I want to find out the output of C of S for the unit step input. In your syllabus, ask you to find out, right? For the unit step input only, derive the expression for the time response of a second order system. Therefore, for unit step input, input R of S is equal to 1 by SO. Therefore, what is the value? C of S value is equal to 1 by SO into W of N square O. W of N square divided by 2 zeta W of N or omega N now R. Now this is the C of S value. Now this is called as second order system. Why it is called second order system? Highest powers of the closed loop transfer functions ಅಲ್ಲಿ denominators polynomial denominator equations ಅಲ್ಲಿ s power 6 ಇರುತ್ತೆ. If s power is equal to 2 ಇದ್ರೆ second order system, s power 3 ಇದ್ರೆ third order system. The highest powers of the closed loop transfer functions of the denominator polynomial of the highest powers of s in the denominator polynomial of a closed loop transfer function decide the order of the system. And after finding the C of S divided by R of S, so numerator term, denominator term, denominator term having the S power is equal to 2 is hence it is called a second order system. Now this is the way of finding the C of S value. Now C of S is equal to 1 by S. For the step input, R of S is equal to M take 1 by S into. Now by using partial fraction method, now we go for by using partial fraction expansion, we go for writing this C of S can be written as like this. By using partial fraction, expanding C of S into the partial fraction, we get the, now this is the get. Now what is C of S value? Now C of S value is equal to 1 by S. So W of N square or omega N square S into S square plus 2 zeta omega N plus omega N square is equal to A by SO plus BSO plus C S square plus 2 zeta plus W of N square or omega N square. After expanding this equation into the partial fraction, then substitute the C of S value is equal to C of S value is equal to this is in left hand side C of S value is equal to substitute, and then now take the LCM. Now W of N square S into S square plus 2 zeta omega N plus omega N square is equal to A into LCM is S into S square plus 2 zeta S into S square S into S square plus 2 zeta therefore this gets cancelled. A into S square plus 2 zeta omega N plus omega N square plus BS plus C into S. Now this term and this term gets cancelled. Now what is the value of left hand side? Left hand side S into left hand side omega N square is equal to A into what is the value of A into S square after simplification? A into S square plus 2 zeta A multiply A into S square 2 zeta A omega N plus 2 now A into plus BS square plus CS. Now this term gets cancelled. Now find the values of ABC. Find the values. Now this is equal to W of N square is equal to a plus b s square plus 2 zeta omega n a s plus c into s plus e into comparing the coefficient of the common terms, comparing coefficients of common terms. Now, what is the a is equal to? A is equal to constant. A is equal to 1. No. B is equal to C is equal to in birthday. What is the value? C is equal to 2 zeta omega n. No. And B is equal to minus 1. No. Now these are the values. Once we find the ABC value, substitute the ABC in equation 1. Once we find what is the A is equal to 1 now, B is equal to minus 1 now, C is equal to zeta. Now by substituting these values ABC in equation 1, by substituting values of A, B and C in equation 1, we get the value of C of S is equal to 1 by SO minus S plus 2 zeta omega n. No. S square plus 2 zeta omega n SO plus omega n square. For underdamped system, I need to find out the C of S for the underdamped system. Zeta is equal to less than 1. If zeta is equal to 1, no, critically damped. Zeta is equal to 0, undamped system. Zeta is equal to less than 1, no, underdamped system. Zeta is greater than overdamped system. Zeta is greater than 1. For underdamped system, the zeta value is less than 1 though. Therefore, the term. Now this is the term S square plus 2 zeta omega n into S plus S square. Now this term can be replaced by the term S plus can be replaced by S plus zeta into omega n plus WD. Now for zeta is equal to less than 1, no, this term can be replaced with the S plus zeta into omega n whole square plus W of D or omega D square. Oh. Now this expression becomes, now this is the expression. So therefore this expression becomes, this term can be written as, replaced with this term S plus 2 zeta omega n square plus omega D square. Now this can be replaced by this particular term. Now expand. Now individually you have to, this entire term is divided by this SC divided by entire term. Similarly, now C of S is equal to 1 by SO minus S by S plus zeta omega n square whole square plus omega D square minus so similarly 2 zeta minus S plus, so zeta omega n square over S plus zeta omega n whole square plus omega d square. Now this can be written as like this. So now by taking for this, now this can be written as like this. Now the term, now C of S is equal to, this is also is equal to, this is also is equal to the, therefore C of S is equal to 1 by SO minus zeta S plus zeta omega n divided by S plus zeta omega n square plus WD square uh, minus zeta omega n by S plus zeta omega n square plus omega d square. Now this can be written as like this. Now this can be written as same thing here. Again, I'm going for multiply this W of d and divided by W of d. Multiplication of damped natural frequency W of d or omega d divided by the base omega d in order to simplification. And then by taking the inverse, by taking inverse Laplace transform, by taking inverse Laplace transform for this quantity. If I take inverse Laplace transform, then C of t is the time response of the second order system. Now 1 minus this can be written as here e power minus zeta omega n t cos of, for this term there is a cos of omega d t minus zeta omega n divided by d, that's omega n divided by this d, and this omega d divided by this quantity can be written as sine of omega d t. Now this is the time response of the second order system. Time response of the underdamped system, second order underdamped system for the unit step input. Further simplification. Now the further simplification of the C of t can be explained in my class notes. You have to go through the class notes. This is for the time response. This is the very important relation we should remember. This is the time response of the second order system, time response underdamped system for unit step input. This derivation is frequently asking in the examination. So you have to go through the class notes or any book. Class notes or any book. Now what is the similarly, if I want to find the time response, I'm going to write the, now similarly we can derive the expression for the time response, expression for the overdamped system, undamped system, and also the critical damped system. Usually this time response C of CT of an underdamped system usually asking in the exam, usually asking in the examination. So but if I want to find out the time response of the undamped system or overdamped system or critically damped system, and go for writing the directly expression. So to remember, similarly we can derive those also, those expressions also. These are the expression for the time response of a second order system for unit step input when critically zeta is equal to 0. The system is called as a critically damped system. Then the time response C of t is equal to 1 minus cos of omega n into t. Similarly, C of t is equal to 1 minus e power zeta into this term is called as a critically damped system. C of t value is equal to, this is the C of t value for the critically damped system, and this is the C of t value for the overdamped system. If zeta is greater than 1, then this is called as a critically damped system. Therefore, C of t is equal to 1 plus W of n or omega n divided by 2 into square root of zeta square minus 1. No, e power minus s1 t divided by s1 minus e power minus st divided by s2. Now this is for the critically damped system. Therefore, these are the expressions. S1 value is equal to this, S2 value is equal to this. So we should remember this while solving the problems. Usually, the time response of the second order system for the unit step input for underdamped system is usually asking questions. So we should practice it, that this derivation usually asking in the examination many times in the examination. Have to go through the class notes for uh, the derivation. So thank you for listening. Next I'm going to explain examples on the time response of a second order system.